Okay, doctor, you can start it now.
دقيقة واحدة. Okay. Just Okay, Assalamu alaikum. Good afternoon. My name is Dr. Ra'ad Chubair, and I am from IEEE UAE. And today I will give you some applications and examples of the use of IoT. IoT is an important topic on one of the technologies that is integrated with AI in order to develop new applications that will improve the way we live, and also it has interesting applications in healthcare, in transportation, as we will see. So let me share my presentation slides. Okay. Can you see my slides? Do you see my slides or you don't?
Yes, doctor. The slides
Okay.
is clear, but put it on the full screen.
Yes. Okay. Can you see now? Full screen?
Yes, it's full screen,
Okay.
but press duplicate. I think you are using a second screen.
Okay, sorry.
Display mode and duplicate.
يعني أعمل إيش حاليا؟
Back to the full screen عادي. يعني دوس حضرتك على الفول سكرين.
صار full screen. Okay.
Full screen. تمام. هتلاقي في حضرتك الديسبلاي سيتنجز.
display settings تحت. اوكي.
لا بعد ما حضرتك عملت فول سكرين هتلاقي فيه فوق خالص في الديسبلاي سيتنجز. يعني اعمل فول سكرين تاني.
تمام. مفيش عندي بوتنز، بيطلع لي بس فول سكرين.
حضرتك بتستخدم سكرين مش اللابتوب صح؟
يس.
هتلاقي في اللابتوب حضرتك في سكند سكرين، دي اللي ظاهره عندنا. بيجيب النكست سلايد. يعني حضرتك اعمل كده فول سكرين من اللابتوب.
اوكي من اللابتوب. Let me stop the share 1 minute، او اعمله من اللابتوب وادخل من اللابتوب. اوكي. اوكي انا من اللابتوب حاليا، فاروح فين؟
حضرتك اعمل شير سكرين عادي وفول سكرين.
عملت فول سكرين وطلع لي اوبشنز كده.
هو الشير مش ظاهر عندنا، فممكن حضرتك تعمل شير تاني.
تمام. واضح؟ it full screen. تمام.
تمام. هتلاقي حضرتك في عندك ديسبلاي سيتنجز فوق خالص.
بيطلع سلايد والسلايد اللي بعدها.
بالظبط. ده اللي طالع عندنا. فحضرتك هتدوس على الديسبلاي سيتنجز وهتدوس دوبليكيت علشان يبقى اللي على الشاشه هو اللي على اللابتوب. دوبليكيت. ايوه، سكند تشويس
كده. تمام.
بيرفكت. تمام يا دكتور.
Okay. Sorry for this technical problem. So today I chose to give examples by explaining IoT applications, and since we are living in the time of COVID, I want to show you how the power of IoT is important for solving day-to-day challenges that we are facing in terms of healthcare or in other aspects of life. So my specific title of my talk will be IoT personalized medicine. So we are re-engineering healthcare through communication and computation technologies. And this summarizes what a sensor is. A sensor is a device, different electronics and sensors and software, they are connected to the internet. So integration of electronics, which involve sensors, which are detecting different parameters depending on what we are looking for, and connecting that data through software integration to the internet, which will be either fiber or wireless. This summarizes what's called Internet of Things. So you are combining the internet with things, and these things are connected to the internet through electronic devices that we call them sensors. Now, applications where we use IoT are, you can find it everywhere. Communication, when we talk to each other, okay, and communicating with devices at home, smart homes, smart transportation. There are IoT as well, because the sensors in the car, they have to sense the car next to it. Or if there is, for example, a car on the front and so on, or there is a red traffic light and the driver is not paying attention. So there are different sensors for intelligent transportation systems. And also from the street point of view, for example, why do I have to keep the street lights open if I'm driving in a highway? Why would I use lights all the time at night in a highway far away from the city if there are no cars? So the new transportation systems now, they use smart lighting systems where they use IoT sensors that will detect if there are any incoming vehicles, and therefore it will trigger the lights to be on before the car arrives. So you will have sensors like 5 kilometers before or 10 kilometers, and they will have to be connected to the internet because they need to transfer the information that there is a car coming to the sensor, which is 5 kilometers after that point. So the only way to communicate that information is through wireless, which is radio systems. We call it radio. Radio is not like a radio that we are using to listen to radio. Radio here, it means electromagnetic waves or the data that travels in free space. So sensors, they detect information, convert that information, whether that information is images or reading or a certain parameter or whatever, and convert it into equivalent electromagnetic wave, so which is invisible, that is transferred over wireless or through optical fibers. So they are used to connect smart homes, smart transportation systems, and medical implants as well. Because the new future medicine will implant nanobio materials and nanobio robots. They call it nanobio robots. These are like living cells, but they are actually integration of electronic and biological sensors that have a certain function to detect early detection of cancer. So as you know, one of the key important aspects to treat cancer is to detect it very early. if we wait for the patient to complain, or if we wait to do an MRI or CT scan or whatever, and then detect there is a cancer in a certain part of the body, it will be too late because the size of the cancer cells will be large that have been detected by MRI. But if we go to the nano and millimeter dimension, which is a very small dimension, we want to monitor any biochemical change inside the body. And this can only be done if we use what's called nanobiorobots. So sensors, you can find it everywhere. Today, because we are all suffering and have been living under the conditions of COVID, I want to show you the power of using sensors for the prevention of the spread of COVID. And as you would know, it will be a sensor to detect any changes in the breathing of the person or any symptoms on the person. Sometimes I only feel I am not feeling well when I start to cough or I have fever. But we want early detection, and early detection cannot be done by the person himself monitoring his own breathing or his own temperature. You need sensors to do that, and sensors are very sensitive. They are called sensors because they are sensitive, and they detect information accurately. So it will any change in the breathing pattern of a person means he's suffering from breathing, so he is like not getting enough oxygen, and this is one of the signs of having a problem in his lungs and getting oxygen to the lungs. So this is one of the symptoms for being infected with COVID. So here we just want to show that sensors have many challenges to communicate information. If I am sensing a person, if I am sensing a person's temperature or some breathing or his walking style or anything about this person, and I'm trying to get that information to analyze it, and that router or that device which receives that information is outside the building or the room or that person, we have what's called reflection and diffraction. So one of the challenges in deploying IoT sensors is that they need to communicate sometimes through walls and through barriers. And these obstacles prevent the wireless signal coming from the sensors on the human body to reach its destination. So this is one of the challenges that we have to deal with. This is why when we want to pick up a sensor, we have to ask, do we have what's called line of sight communication? All the sensors will be in the same place and there will be no barrier, or we are assuming that these sensors should be able to communicate with each other through walls and barriers. And therefore, we have to take the sensor with the proper transmitted power and the proper sensitivity or detected power. So radio signals do not only capture the movement of the person, but also his health. Because the wave that is reflected from a person does not tell you where is the location of that person. These waves, if you use the proper sensor, you can also detect his breathing pattern or his heartbeat, and I will show you. So monitoring people and their vital signs using radio signals and machine learning is one of the aspects to applying IoT technology for healthcare. Because IoT in healthcare means I'm using sensors on this person to detect, for example, his breathing or his heartbeat, communicating it through radio waves. And when you detect that wave, you will analyze it using data processing techniques or machine learning in order to detect any change in the regular pattern of that person. We cannot do this physically. Only using machine learning can do it. And machine learning is an important tool that is used to detect any hidden patterns. Because when there is a lot of data we are unable to detect if there is anything wrong with the data, if we have a large volume of the data, only by inserting that data to an algorithm, and that algorithm will be able to find out if there is any changes from the normal pattern that this or a certain function or a behavior we are looking for. So we are combining radio signals with machine learning. So let's, for example, see how to do it in a normal home. So in order to have IoT sensors in a home for healthcare applications, we have a device like this one. This will detect all the readings from the sensors on the people in that house, and it will process those signals, and it will tell you if there is one person that is, for example, suffering from a breathing problem or a fast heartbeat problem. So now technology has evolved in a way that we can mount something like this on the wall. It goes with the decoration of the house without any problem, and it does not interfere with the health of the person, because the amount of power transmitted and received from this device is up to the standards that is allowed for electromagnetic waves. So it does not impact the human health. It's like using your mobile next to your ear. There are no harm from having mobile signals or mobile phone signals around you, because the power of that mobile signal around you is at a level that does not impact your human body. So the same thing, of course, in UAE, the organization which approves any electronic device that has some radiation or works at a certain frequency is the TRA. Now it's called the digital TRA, because TRA approves any equipment or device before it is sold in UAE. It has to go through the labs of the TRA. They will have test equipment. They will verify that the specification of that device on the box, that when you buy it, those specifications are real, and that device does not emit a strong wave, because you don't want your sensors to get information but transmit it at a high power, because high power can impact a human being who's using those sensors, as well as it can introduce interference with other sensors. So the sensors that we can use can detect breathing or heartbeat and other, for example, what's called gait speed, because why it's gait speed means the speed of walking in a house. When you have elderly people, you want also the sensor to detect their walking pattern, if they are walking properly or they are getting slow, or if they are not even moving. So it's not enough to detect a person breathing or heartbeat, because if he's sitting all the time on the sofa or in his bed, it means he's not able to move, and he doesn't know that he's not feeling well, especially elderly people, if they have certain diseases, or they have they are not able to talk or whatever. Also sleeping pattern. People sometimes suffer from sleeping pattern without knowing. So these sensors can detect different things about the person, and this is important. Now for COVID, the most important thing is the breathing. So let's see. For example, a person is in a certain room here, and another one is here, and the radio signal can cover from that device, can cover all the rooms. So you don't need to mount that device in all the rooms. The coverage area covers all the house, and you can have people in the same room with the device or in other rooms. So we will see here how is the behavior of the person, his eating pattern, his everything. So, and sleep pattern as well. So for example, sleeping pattern, people think when they sleep, they were just awake and to sleep, you need to go into 4 phases. To reach from awake to deep sleep, you have to go through these 2 stages, which is intermediate stages, light sleep, and before that is this one, which is rapid eye movement. So you will find now, if you don't use IoT sensors, you need this. If you don't use Wi-Fi, for example, or you don't use radio waves, your sensors, which are mounted on the brain or on the head, will have to be connected through wires. So this is the advantage why IoT has to be integrated with the internet or Wi-Fi, because if you don't integrate your IoT sensors with wireless, you will end up with a lot of complicated circuitry and too many wires. So this is not healthy if you want to measure a parameter or a certain parameter about a person, to have all these sensors connected to the device that will analyze them through wires. So for our Wi-Fi signals, you will see here that these states going from awake state to deep state. You can see the pattern here. Okay, this is for a normal person. Now, if that state takes a lot of time for that person, so this, what does this mean? It means that this person goes in deep sleep only in short intervals of time. And most of the time he is in the light sleep mode, or yes, the light sleep mode. So it means this person is not cannot go fully to sleep. And this is important for neurological diseases like Parkinson or depression or bipolar disorder, because the hormones in the brain affect the sleep. So one way to know if any person is suffering from early symptoms of depression or brain diseases, other brain diseases, is to monitor their sleeping pattern. And their sleeping pattern can be monitored by having these sensors on the person's head, okay? But they are, very tiny that the person cannot feel, but they are communicating. They are able to detect the type of the wave in the brain, and based on that wave in the brain being analyzed using ML, which is machine learning, you can tell at what state this person is. Now, breathing, you can also, being sitting in a library or in the office or in a classroom and reading something and breathing normally. And that sensor that detects breathing will send that data to a device that will analyze your breathing pattern. You can, this is a normal pattern. You can see if the person is holding his breath, what will happen? His breathing pattern will change, will be fixed. It will not oscillate like a sine wave. So this means that those sensors are very sensitive to the point to check if your breathing is normal or slow, or it is even not really good. It takes you more time to take oxygen. Usually you should be able to breathe in a shorter period of time. And the breathing time, inhale, exhale, should be almost equal. So if it takes you more time to inhale, it means you have a problem with your lungs. And this is an early sign that you need to check whether you are infected or not, or have a flu, or is it COVID or fever or whatever. So the person himself thinks, I am fine. Unless you are running in a marathon, you will not feel that you have a breathing problem, because you can, the body can adapt if the amount of oxygen is less. But only using sensors and machine learning and analyzing the breathing regularly you will be able to do early detection. So remember, what we are trying to do is to do early detection, because eventually if somebody have a breathing problem, eventually he will know. But the point is to get that knowledge early, even before myself who has an issue is notice it. I don't want this to become a physical symptom that is affecting my lifestyle. So this is why we are really using healthcare or personalized healthcare using IoT sensors. And what I am showing you, these are actual applications that have been deployed and existing. So if you exhale, you get the peaks. If you inhale, you get the down peaks. And therefore, it is important to detect any changes in the time period it takes to inhale and exhale, and any change analyzed by machine learning you will be able to detect if there is an issue with that person, and therefore try to help him at an early stage. Now, for example, this was an experiment done on an old person who was living in just one bedroom apartment or a studio. And this is the bathroom, and he will sleep here, and he will sit and watch some sofa and table and window. And here is a small counter for kitchen at the entrance. So this is the trajectory. What you see in blue here is the trajectory of the movement of the person. Over 24 hours, they analyzed the movement of that person which is suffering from Parkinson to see what is his pattern. So you will see that most of the time, he is around his bed. He goes to sleep, or he sits here on the table to eat, or, and then he goes to the bathroom. So if you will find that most of his activity, now you don't see that person because it's private. You cannot get into the house and watch what he's doing. But he is carrying a small sensor or a device mounted maybe on his watch or in his neck, or put around his stomach, a small device. That device can measure his steps and where is his location in the room, and will send that information to another central device with machine learning, analyze his movement. So even if his doctor is not around, or the nurses and the doctor who are monitoring this person while he is at home, they will know if he is behaving normally. Because these people with Parkinson, for sometimes, because they are really old and they have Parkinson, they might not pay attention. They might suffer from a certain thing. They might, feel down and so on, and they're not able to reach out to somebody to help them. So it's important to monitor them remotely, but not break their privacy. And this can only be done if you use IoT sensors and Wi-Fi, which is wireless, and analyzing the data from these sensors using machine learning. Again, this is another way to show that people with Parkinson can be different people. These are 6 people who have Parkinson, but the patients 1, 2, 3, 4, 5, 6, you will find out, for example, this patient has a regular pattern, because here you take the trajectory of that person around 24 hours, but as a circle. You will find that this person goes to sleep at the same time, regularly, every day, every day, every day. This is every circle represents the trajectory of that person on that day. So if you take the trajectory over 30 days, you end up with this graph. You will find at around the same time every day, this person trajectory is in one area, which will be his bed. However, this is the worst case, the one on the below him. Why? Because this person means every day, all the days, he's not consistently sleeping at the same time. the trajectory of his sleeping pattern changes. So in one day, in early, he sleeps around this time of the day. Then as we move on, he sleeps around another time. So he is not sleeping regularly. So this person means we raise an alarm. This person needs the health service provider to check on him, not wait for him to ask for help. So these are examples. How can we use remote healthcare monitoring using IoT healthcare sensors in order to monitor patients without breaking their privacy? So we will only intervene if we see an irregular pattern. This patient 6 is regular pattern, patient 5 is not bad, but the worst one is this one. Now the more interesting one, which is the COVID thing. As we said, COVID is a very tiny virus. We cannot detect it if it's inside the body, once it's in the body, until the technology reaches a point where we can do that. We don't have, for example, sensors that can be mounted inside the mouth or in the nose to detect any incoming object and analyze what is that object. But I am sure technology will reach that point one day. Because 100 years ago, nobody thought that you can be in one country and speak to another person in another, well, like maybe 2,000 kilometers away in another country at the same time. Nobody thought that we will invent wireless signals and mobiles and so on. So from what we can see and from the need of the technology, from a technology point of view, we anticipate that we will reach a point where we develop a biosensor that will be implanted in maybe the nose of the person or his mouth to detect any incoming object, like, for example, viruses and so on. Now, at the current point of time, the best thing we can do is to monitor the person's breathing pattern, inhale and exhale. So we are showing here two patients. You can see here the breathing rate is 23 for this person on the left. The breathing rate became 18. First time, for the first time, COVID-19 has been monitored using new contact-free wireless device. So this slide means that what we are doing here is that we were able to detect the breathing pattern of that person and identify whether he has COVID or not. As we said, a COVID patient is a patient with irregular breathing pattern. I will show you in this example. Look at this person. These are the dates where we are measuring his breathing pattern, like 8th of April, 9th of April, 10, and so on and so on. We notice a similar pattern from 8th of April up to 13. But on 14th of April, his breathing pattern has a shift. And that shift means it's severe shift. It means it's a drastic change. He was breathing at a rate of between 15 and 20, which is say like 17 or 18. He is now between 15 and 25, so around 22. So it means his heart is beating faster to get the same amount of oxygen. So it means he's suffering from breathing. He has a breathing problem. So he needs to be taken to the hospital. I don't need to wait for this person to have other symptoms of COVID. He might not notice that he has a breathing problem from one day to another, but only through the sensors that are detecting his breathing and analyzing the pattern, through machine learning, the health service provider, the doctor, will see that there is a shift in the rate of his pulse, or sorry, the rate of his heart, and therefore he will decide that this person has to be called to check his other parameters, and he needs to be hospitalized in the case, and taking blood samples to analyze that if he has COVID or not. So this person needs to go to the hospital. This is a smooth recovery person, because although there is a change in the pattern, but the breathing peak remains in the same, around the same range. There isn't a significant shift like the one on the left. The one on the right is a perfect person, is a person without any breathing problem, because his heart beats at the same rate every day almost. So why it is important? Because if you remember when COVID started, there was a problem with the hospitals accommodating too many patients. So we need a solution to say which patient should go to hospital, which is patient number one, because the change or the shift in the breathing pattern is large, and which patient can still, I mean, okay, he has a breathing pattern which is not ideal, but still he can manage on his own, so he can stay at home. He doesn't need a hospital. So he gets a smooth recovery. No need for hospital. And this way you are saving the resources of the hospital, and you decrease the burden on the medical system. You don't put a burden that there are too many patients unnecessarily occupying beds in the hospital, where other more important cases could use these same resources. So it's important. Now, without the use of IoT sensors from the beginning, all of this would not be possible. How can I detect the breathing pattern? Now I am sitting, for example, in the university giving this lecture, and you are somewhere else in another emirate or another location. How can I monitor your breathing or any symptom about you? Only when I use IoT sensors around you, which is sensors to detect the heartbeat, but also importantly to communicate that information. Communication, sensing and communication is combined by IoT. So IoT summarizes two things: sensing, which is taking the information, and then communicating it through the internet or Wi-Fi. So what we are doing, we are converting wearable sensors to invisible sensors. So the picture for that person, everybody now, if he sees that person, knows he's wearing some sensors, because these are wearables and connected with wires. But we can implant a small sensor behind his ear, or near his chest, to monitor the heart without anybody knowing. So they are more, they protect the person's privacy, IoT sensors, and they help by converting information to become invisible. So the information is being conveyed through wireless signals in an invisible manner. So the topic of IoT and machine learning and big data, combines different fields together, which is antennas and propagation, because you need to understand how a signal gets detected. Then wireless communication, which is moving the signal from one point to the other. Signal processing means to remove the noise from the signal. We need nano bioscience and nanoscale sensors, which is called nanomedicine. Nano here because means very small. The reason we want to make our sensors very small, so that they can detect any small changes in anything we are trying to find. And of course, machine learning, which is AI techniques and the power of computation. So you can see any application you pick up in any application. Today I gave applications from healthcare. But if you apply, like, for example, smart grid or, for example, smart transportation systems, any application you pick up, you will find that IoT comes with a number of multidisciplinary fields. You cannot just learn how to design a sensor and put it somewhere to take some readings. You need to integrate the sensor with other tools in order to make use of the information that the sensor will provide. Next one. So I think I don't want to go more deeper, but I am ready to answer any questions. I have more slides, but they are more technical, and I can share with them, with anybody interested later, and also the references I can provide later. But this is just to give you a general idea how IoT is important in our life. And one of the most important examples we give, because we all lived under the circumstances of COVID, is without the use of IoT sensors for healthcare, it would have been almost impossible to counter COVID. How did the governments and the health authorities know the behavior of COVID? Only by using sensors and detecting who gets infected and how many people around that person got infected. So only through the sensors you are able to see the spread of the virus, and then you can take precautions to stop that and prevent that from happening or stop it from growing. And also for early detection of COVID, not only the spread of COVID. You want to know if there's another person gets infected, it's important, but also you want to early detect the virus so that the spread does not even increase. So sensors are very important in our lives, and in any application now that use in our life, you will find somehow that there will be IoT sensors between the transmitter and the receiver, or between the user and the base station. So I will stop here. Be happy to answer any basic questions on IoT and so on. Any answers? Any questions from the audience? Okay. Thank you for your attention, and I hope to see you again and to contribute in other events in the future. I have to go to another meeting, so I have to apologize, and see you later.